This podcast is about Avogadro's number and how we use it to count something that we call the mole. So chemists need to have a good way to count things. We have to be able to count atoms or ions and molecules, depending on what we're talking about. And they're way too small and the numbers are way too big. So instead, we use the mole as a counting unit. And 1 mole is exactly 6.02 times 10 to the 23rd particles of anything. We use it to count anything. So this number, this 6.02 times 10 to the 23rd, is a huge amount. Just to give you an idea of how big it is, if you lined up periods typed with a computer, lined up side by side, it would be the radius of the galaxy. If you had a mole of marbles stacked tightly together, it would cover the United States 70 miles deep. However, you can swallow a mole of water in 1 gulp, 18 grams. So that's how tiny water molecules are. So our connection between AMUs, which is a way that we count single molecules, and laboratory-sized sample that we are actually going to measure, is the connection between atomic mass and molar mass. And molar mass is what we use in the lab. But these numbers are exactly the same. So 1 AMU equals 1 gram per mole. Another way to think about that is if we're talking about water, water has an atomic mass of 18, and it has a molar mass of 18 grams per mole. So that is the connection, and that is how we use molar mass. So converting back and forth between moles and particles, we're going to use Avogadro's number. If we had 1 mole of carbon, 1 mole, it would be exactly 6.02 times 10 to the 23rd carbon atoms, because pure carbon is made of atoms. If we're talking about O2 molecules, and we had 3 moles, it would be 3 moles times 6.02 times 10 to the 23rd molecules per mole would be 1.8 times 10 to the 24th molecules. How many oxygen atoms would that give us? Because each molecule has 2 atoms, it would mean the number of molecules times 2 oxygen atoms for every molecule, so that would be 3.6 times 10 to the 24th. 2 moles of aluminum chloride, multiply 2 by Avogadro's number. That would give us the number of formula units of aluminum chloride. Aluminum chloride is ionic, so we cannot call it a molecule. It's a formula unit. How many aluminums would that have? Every formula unit has 1 aluminum, so it's going to be the same number. How many chloride ions would that have? Each formula unit has 3 chlorides. Now notice that we're looking at the formula here, AlCl3, because of the 3. It's going to be 3.6 times 10 to the 24th chloride ions. How many moles of CH4 molecules would we have in 2.45 times 10 to the 24th? We're going to work backwards here. So we have the number of molecules. We know the number of molecules per mole, that's Avogadro's number. Divide by that number, and we get the number of moles, 4.07 moles.